Welcome back, everybody. We are going to talk about basic rules of exponents today. So this is number 17 in your notebooks. And we are in our new unit, Unit 5. And so just a quick little heads up on exponents. You will always have a number on the bottom, which is what we call the base of the exponent. And the exponent or power is literally in the upper right-hand corner of the base. So if we have positive exponents, you guys know that the positive exponent means multiply me by myself that many times. So if I have 2 to the power of 3, that means take 2 times 2 times 2, which ends up giving us 8. 2 squared is 2 times 2, which is 4. 2 to the first power means literally only 1 2 is written. And so now we can write a key little concept here. So that's multiply the base by itself the exponent number of times. So our power or our exponent was 3, then 2, then 1. Now, I'm hoping you guys are seeing a pattern emerging here between your numbers because that's going to help us with the zero exponent and negative exponents. So to go from 8 down to 4, we divided by 2. To go from 4 down to 2, we divided by 2 again, which means to get this zero power piece, I literally would take 2 and divide it by 2, which ends up giving us 1. A lot of people, anytime you have a power of 0, you think it would be 0, but it's not because you're technically taking the base divided by the base. So I'd like you to write that down under zero exponent, that the base divided by the base gives you 1. So that is a key rule that you'll need to know. So if we continued our pattern, we would get our previous answer 1 divided by 2, which is a half, or we can think of this as 1 over 2 to the first power. Again, if I divide by 2 to get my next block here, I would end up getting a half of a half is a quarter. Or you could write that as 1 over 2 to the second power. If I cut a quarter in half, I end up getting an eighth, or 1 over 2 cubed. So what does this tell us about negative exponents? Well, negative exponents are not whole numbers. They are fractions. So they are written as a fractional amount. So they're written as fractional amounts, and when you have a negative power and you rewrite it, it now becomes a positive power. So you can actually calculate with it. That's handy when you're working with science values, when things are really, really small and when things are really, really, really big. So here come our examples. So in example 1, I'm multiplying these two things together. So I'm going to take my negative 4 and multiply it to 2 to get negative 8. X cubed means x times x times x 3 times. And x squared means x times x. So if I am multiplying these all together, how many x's, or what is the new power that I can write on the x now since I wrote them all out? Well, I don't see 3 and 2. I see all together 5 x's. So our answer for our first example is negative 8x to the power of 5. In the second example, I do not like that x to the negative 6th power. We do not like negative powers. So we need to rewrite that piece first. How we rewrite it is we force it to go to the bottom. When you move the negative power, the power now becomes positive. So now this has changed from multiplication to division. So how do we handle that situation? Well, I have 9 x's on the top and I have 6 x's on the bottom. So I wrote out all my x's there to make this a little bit easier. So the question is, am I top heavy by my x's or am I bottom heavy by my x's? So if I start partnering up, you're going to notice that you are definitely top heavy. And in particular, once you have nobody else to slash out, we are top heavy by 3 x's, which means my answer is x to the power of 3, since I have 3 of those. And you could put this over 1 if you wanted. Or we could just write this as x to the power of 3 as our final answer. On example number 3, we notice our negative out front, so I'm going to keep the negative there. I see parentheses. And outside of those parentheses, I have a power of 2. So that means that's what's overtaking everything else in my question. So a power of 2 means multiply me by myself twice. So you're going to take what's inside the parenthesis, the base, and take it to that power. The power many times, so twice. Okay, so now we need to take a look at what we know. Well, a negative 9 times 9 would end up giving us a negative 81. Is negative 81. Oh no, Miss Weldy, number 4, I'm out. As soon as you see that divide bar, don't freak out. The first thing I want you to identify is we've got not one negative exponent, but we have 2 of them. So we need to take care of those negative powers first. So let's start with the top, the y to the negative 3rd power. Because that's a negative power, we're going to throw it to the bottom, the opposite. And when you throw it to the bottom, guys, that 3 becomes positive. Now we have an x to the negative 6 that is currently on the bottom. So to move him, we've got to move him to the opposite, which is the top. When you move it to the top, it now becomes a positive power. Once all of our powers are positive, now we can write out how many of those x's and how many of those y's we've got. So up top, we now have not 2 x's, not 6 x's. All together on the top, I see a number of 8 x's. So my new power of x on the top is 8. On the bottom, I don't see 3 y's, I don't see 4 y's, I see a total of 7 y's. So my new power of y is 7, and they are on the bottom. Now the last thing you want to do is actually do this operation. 15 divided by 3 literally is a number. That ends up giving us a 5 over 1, or you can just write it as a 5 on the top. So our final answer is 5x to the 8th power divided by y to the 7th power. On example 5, we have parentheses with a power of 3 on the outside. So remember what the power of 3 means. It means times me by myself 3 times. Now when we write these out, SpaghettiOs, we don't like those negative powers on the w's. So when you have negative powers, we rewrite them. And we rewrite them on the bottom. So we're going to put a w to the first. So as we write these out, we have 2 times 2 times 2, which ends an 8 up at the top. Z cubed times z cubed times z cubed. gives me a brand new power on z, which is a power of 9 z's are on the top. And down on the bottom, how many w's do we see sitting there? Well, we see 3 of them. So w to the 3 on the bottom would be an acceptable answer. So 8z to the 9th divide by w to the power of 3. Number 6, guys, I see parentheses, and I see it to a power of a negative. Yikes! How do we handle negative powers? That's right, we put it down on the bottom. And now we need to attack the parentheses. The power of 2 means take me times myself twice. Remember, when we move the negative power to a different location, it changes to a positive exponent, which means we can rewrite this so that we have 5 times 5 on the bottom, f and f, g to the 4, g to the 4. And now let's figure out how many of each we've got going on here. On the bottom, we have 5 times 5, which is 25. There is a new power of 2 f's on the bottom. If I have 4 g's and then another 4 g's, altogether we've got 8 g's on the bottom. And now we need to figure out how many are remaining and where. So according to what we see, am I top heavy or bottom heavy by f's? Looks like we're top heavy by 4 f's. And in terms of our g's, are we top heavy or bottom heavy? Looks like our g's are bottom heavy by 3. So what does that tell us? That tells us in our final answer, we will be top heavy by 4 f's, so f to the new power of 4. On the bottom, the 25 stays along for the ride. And we were bottom heavy by 3 g's. So our final answer is f to the 4th divided by 25g to the 3. So here's a couple of things that you want to keep in mind as you're working through your exponent. You want to move your negative exponents so that you can make them a positive power. The parentheses means that you multiply out the exponent number of times. So the parentheses will tell you how many times do you times it by itself. Last but not least, when you multiply and divide, you want to write out the exponent number of times and then do the operation given. Now let's practice.